All right, so welcome back. Happy Friday. Today is September 16th. It is our 5th class. It says Project 1 is due. That is a lie. I changed the deadline to Monday coming up. Hopefully we've got some progress already made on that. In theory, you can download GeoGebra for free onto a wide variety of computers and tablets and things like that. But if you don't want to get involved in any of that, you can use the computers in the Math Studio across the hall. GCC is open on Saturdays. I think that this room is unlocked, but there won't be any math faculty members to cover tomorrow. But in any event, you can use the computers. Today, we're covering linear models and applications. That is to say, word problems. Any questions on anything on the calendar? Okay. So taking a look at 23, let's just run through some of these real quick. Get some answers in here. The first one says the width is x and the length is x plus 200. We want the perimeter. How do you find the perimeter of a shape?
Sum of all sides.
You find the sum of all the sides, right? So before we simplify, there's an x and there's an x plus 200. I'm going to put parentheses in that aren't required, but just allows us to see clearly. One is the width, one is the length. Is that it? Is that the sum of all the sides? What else? Yeah, I'm going to do it in a more naive way than that. Plus what? Yeah, plus another x, because there's two widths, and then plus another x plus 200, right? And so, yeah, that's good. But it's really easy to make that mistake to say, oh, I just have to add the sides, and there's only two sides, and you only add the two things, and then you've missed the other length and the other width. Okay, and then so simplifying that, we just smush all together 4x plus 400. I think that's that. And then for part B, an algebraic expression that models the rectangle's area. So we know area for a rectangle, yeah.
You don't have to like factor that.
You could factor. What did you write?
Either way, correct?
Either way is okay, yeah. Typically, so you mean something like pulling out the 4? Yeah, no, either way is good. Typically, if we want you to factor, we'll say factor. And otherwise you don't necessarily need to. Simplify means like clean up as much as possible. Suppose that that there were a fraction here with a 4 underneath it. If you don't factor, then you miss the possibility of canceling, and I would say, yo, you didn't simplify as much as you could. So factor is just one of the tools that you might use as you simplify, but it's not mandatory. It's not a synonym for simplify. Good question. Okay, so I'll just write the word here, or either one is okay. All right, so algebraic expression for the area. So just in English, length times width, right? So we just multiply x times x plus 200. And that's fine. Is this factored or distributed right now? It's already in factored form. It's just kind of naturally in that form because the area is a product, length times width. So I'll put again a big old or here. You're welcome to distribute that if you wish. Either answer is full credit. Okay, moving on to number 2. 2 I think is a lot tougher than 1. If you have 3,000 to invest in 2 accounts, one of them pays 2% annual interest and the other one 3.5% annual interest. X represents the amount you invested in the 2% account. Write an expression that represents the amount invested in the 3.5% account in terms of X. So there's a lot of words in there and there's a lot of numbers in there, and to be honest, very little of the information we have is actually useful in this problem. And so getting to the answer here really involves just like putting the blinders on and focusing only on the thing that's important, which isn't a lot for part A at least. If you really have no idea how to start, you're not alone. There are a lot of people that don't know how to start with a problem like this. The way that I start is I just pick an X. This is a technique that that I recommend in 096 when I teach the course before this one, and I'll still recommend it here. If you don't know what to do with X, pick a specific value of X. X represents how much you invested. You have 3,000 total, so it better be something less than 3,000. How about we say 1,000? Just make up a number. For example, X equals $1,000. If you invest $1,000 in one of the accounts, then how much will you be investing in the other account given that you have 3,000 altogether, 2,000, yeah? And so then like the answer is 2,000. If X is 1,000, then the other account has 2,000 in it. So you just have to unpack, what did we do specifically? What did we do to the 1,000 to get the answer of 2,000? We took 3,000 and subtracted off 1,000, right? And it might be so obvious to you that you don't even realize that's the calculation you did to get the answer of 2,000. So in general, it's not 3,000 minus 1,000, it's 3,000 minus X. That's the answer here. That is how much we have left over for the other account. It's really tempting to put 2% in there and 3.5% in there, but that doesn't have anything to do with how much you put in each account. The percentages are going to come and play when we talk about the interest that we earn. But on day one, there's no interest. It's just 3,000 split into two pieces. There it is, 3,000 minus X. Okay, I'm going to jump to part C. I think that's an easier question than B. Represent the amount of annual interest earned in the account paying 2% in terms of X. So we know that, like, let's say you had all $3,000. Say all of that is invested in 2% interest. So how would you calculate the interest for 1 year? Ivy?
0.2x.
So can you give me, not X just yet, but using those two now? I think you're right, but using just the numbers, what are we doing?
Start with the base number of the initial amount invested.
Hmm?
And for 1 year's time, that's going to be one separate variable. And the amount of interest that we get for 2% or 0.2.
Hmm? And if we have 3,000 that we're investing at 2%, Ivy's got the right idea. We're multiplying, right? You are just taking 2% of 3,000, 2% of whatever you invest. And so the first thing she did was exactly the answer here. She said 0.02x, which is the percentage times the amount invested. So that's that. 0.02x is the answer there. But again, I think concretely before I think abstractly. X is abstract. But if you just ask me how to calculate interest, I say percent times whatever you invest. There it is, percent times whatever we invest. Part B says how much interest did you earn in the 3.5% account? It's the same idea. It's still going to be the same formula in orange here. It's the percent times the amount invested. Let's write it. What is the percent for this account? 3.5, so we got to change that to 0.035 multiplied by, in English, the amount invested. Now the amount invested is somewhere on this paper. What represents the amount invested at 3.5% is the answer to A, right? It's that 3,000 minus X. That's it. It's still the same formula, percent times amount. It's just that the thing representing the amount is more complicated than plain old X. It is now 3,000 minus X. Okay, so we're not going to do number 3 together here. You can try it later on. I don't know that many groups had a chance to play around with it. So let's just move on to the teaching demo here. We'll look at some more examples of some of these word problems. Let's take a look at number 2 here. It says, let's begin by looking at the following bar graph that shows the average yearly earnings in the US for people with a college education by final degree earned. That's a lot of words. I need to take a moment to digest the table, and then I can go back and look at the words again if I need to. So what's going on the horizontal axis here? What are those? Different kinds of degrees. Left is the bachelor's, and then a master's, doctorate, professional degree, okay? And then I look at the axis, the vertical one. I see some dollar amounts here. Average yearly earnings in thousands of dollars. Average yearly earnings in thousands of dollars. And so, so for example, if we had to just estimate this top number here for the first bar, maybe 55. So meaning that the average person with a bachelor's degree makes $55,000 per year. That's what it means. And I really need to get down to that level of detail for me to be comfortable reading, like answering anything about this. I got to understand just one specific piece of this graph before I go farther. So okay, I think I see what's going on here. Let's take a look now at the question. It says the average yearly salary of an American whose final degree is a master's is 49,000 less than twice that of an American whose final degree is a bachelor's. Combined, two people with each of these educational attainments earn 116,000. Find the average salary of Americans with each of these final degrees. Okay, so let's give this a shot. Okay, the first thing that a lot of folks want to do when they see a problem like this is write an equation. And I want to caution you against doing that. Because if you got an equation, then you got to have a variable in there. And if you try to write an equation without having a clear understanding of what your variable represents, it's not going to be so pretty. And so you got to make sure that the first thing you do is think carefully about what your variable is. I mean, you can call it X, you can call it X in every problem, but you got to think about what it represents. Let's give it a shot. Let X equal. Okay, what we are after, just looking at the final part of this question, is the average salary for somebody with a master's and somebody with a bachelor's. So if I'm picking X to be something, I feel like it should be one of those two things. Either X should be the annual salary of somebody with a bachelor's or with a master's. Now it turns out one of those choices is going to make it a straightforward problem for us, and one of them is going to make our head kind of sort of go twist into pretzel shape. And so armed with my two choices, I'm just going to look at this sentence again. It says master's is. That's all that I need to see. There's complicated stuff after the word is, but I know that is becomes what in an equation? Is the equal sign. So wouldn't it be lovely if it was something like, oops, it'd be lovely if it was something like, all right, so what they're telling me is that the master's is something, something, something with the bachelor's degree in it, right? There's some formula going on there. So then it feels to me like if I just choose the variable to represent this B, which is floating around inside of some chaos, then I can come up easily with a formula for the master's salary. I don't want to let X be the master's. I want to let X be the bachelor's formula. So you're welcome to do X. I'm actually going to change that to a B, just easier for me to remember what it represented at the end of the day. What if I say let B equal the bachelor's salary? Salary is a quantity word. Every quantity word has to come with a unit word as well. What are we measuring the salary in? Thousands of dollars is the best choice. Not even just dollars, because if you say dollars, then you're going to have to put 3 zeros into lots of places in our equation. In thousands of dollars. Okay, then the formula for the masters. I'm actually not even going to call it M. I'm going to call it masters. I think we can get away with just the one letter here, just B for bachelor's. But a formula for the salary for the masters is given by the gobbledygook that we stopped reading. Masters is, great, I got it. Masters is, masters equals 49,000 less than something. What am I doing? 49 first or 49 second? Second. And less means subtract. That's 49,000 less. We've got to be comfortable having a little gap there. It's about to get filled in. Less than twice that. Twice that means 2 times. The gap has gotten smaller. Yeah, American whose final degree is a bachelor's. That's what we call B or X. There you go. 2B minus 49. That's the translation of that sentence. That the master's is 2B minus 49. Okay, so I think we are golden because we now have the bachelor's salary is B, the master's salary is 2B minus 49, and finally I'm prepared to write a single equation, which I have not yet done. These are just definitions, right? Now we get an equation we're going to solve. Combined, oh, I know what combined means. We're going to be adding. Combined, two people with each of these educational attainments earns 116,000. Great. Where's the 116 go? After the equals, 116. The two salaries are the things we are combining, the things we are adding. What are we writing first? B, that's one of the people. What are we writing second? 2B minus 49. That's the other one. Solving the rest of this problem is a piece of cake. This is the hard part, is getting to the equation. And again, so many students think, oh, that's the first equation. The first thing I should write is the equation. And if you do that, you're taking the hard part and making it even harder on yourself. Because getting to that equation for me was a very thoughtful, thorough process. Solving the equation is like, it's elementary. It's just a process that you're going to follow every time. The thinking has happened already. The rest of this is pretty mundane. Okay, so if we can solve the equation, it's actually not all that interesting from here on out. Add the b's together, so we go 3b minus 49 is 116. Add the 49, what do we get here? 50, 65, is that all right? Okay, so b is 55. Oftentimes in an algebra class, if you find the variable, you're done with the problem, but the problem here didn't say find b. In fact, b is something we invented, so we're not done. We still have to make sure we really answer the question. In this case, the question was find the average salary for each person. So there's going to be two answers, and we've got to make sure we're clear about what they are. So if the B is 55, what color is the best place to go to find the masters? What color is the best place to go? I know B is 55, and I want the master's salary. Blue? Yeah, blue, right? The master salary equals. Great, it's right there. It's ready for us to just read it off. So that means that the master's salary is 2B minus 49, right? 2 times 55 minus 49. And again, what is it? 110, what is it? 60, 61? Yeah. And we took a part of this problem that might have been tricky and we made it trivial. Look, all we had to do was find the equation that we wrote that said master's salary equals. It was obvious to us where to go. But if you are jumping right to here and you don't write any of the other stuff, even if you got all of this in your brain and you get the equation right, you still are giving yourself more work to do to try to find what the master salary is because you haven't taken the time to just write it out. So not only is writing it out, I think, more reliable and more accurate, but it makes things easier for you. Don't look at it as like an extra step. Think of it as a step that makes the problem easier, right? That's what it's for. It's not for me to take points off. Like that's not why we ask you to write the variables down. It's to help you solve the problem. So take your time with the beginning steps here. The equation is really one of the last pieces to these puzzles. What did we say? 61? Okay. So those are our two answers. Maybe we'll just write a short sentence here. There we go. Okay. So the bachelor's salary is, so what's missing here if I say the bachelor's salary is 55? Yeah, so for sure, make sure that you put zeros in there. Totally cool to define B and get 55 for B, but B was in thousands. So make sure you give a realistic answer here. What else is missing? Dollar sign, right? 55,000 donuts, 55,000 yen. There are a lot of ways you can get paid. This problem is about dollars. So the bachelor's salary is 55,000 and the master's salary is 61,000. Last word of caution about these word problems is in the sentence. Some students like write a lot, like a whole heck of a lot more than we need to on the sentence. I just looking for bare minimum. Tell me the answer to the problem with a few extra words floating around. So some people think that they are supposed to like write out the whole process that got them to the answer. It's like, oh, I took the bachelor's salary and I added twice the bachelor's salary less 49,000, and the total was supposed to be 116,000, and I got 55,000. Okay. I'm not getting paid by the word here. Just short and sweet. All right. Okay. So I think that is good there. On the next page, there is a sort of a step-by-step process. I just sort of talked us through this process here. We're not going to fill anything in on this page, but you're welcome to know that, like this is here for you as a reference. The activities start on the next page right up there. Again, the very first step is going to be carefully define your variable or variables and be patient with yourselves. These problems are hard. I'll walk around.